Reports claim that North Korea carried out what it called the demolition of its nuclear testing site at Punggye-ri. According to the media, a series of explosions destroyed underground tunnels once used for atomic experiments. Yet one question remains: was the site truly abandoned, or only partially disabled? To understand the stakes, we need to go back to September 3, 2017. On that day, the ground beneath Mount Mantap, in the northern part of the Korean peninsula, shook violently. It wasn't an ordinary earthquake. Seismographs recorded a tremor of magnitude 6.3. According to the regime itself, it was the largest nuclear test they had ever conducted, a bomb with explosive power ranging from dozens to hundreds of kilotons. Deep within tunnels carved into solid granite, nearly 2 kilometers underground, the device was detonated. Within seconds, shock waves rippled through the mountain, powerful enough to be felt across the border in China. But the most chilling discovery was not just the force of the blast. It was what happened to the mountain itself in the moments that followed. And before we reveal what scientists uncovered, make sure to subscribe to the channel so you don't miss the next stories that will leave you in awe. The Chosen Mountain. It was the moment many scientists called a turning point, and the moment the world began to ask, how far could the damage go? In just seconds, everything changed. When North Korea chose to accelerate its nuclear testing program, one question guided every decision: where can you hide the unimaginable force of an atomic blast? You don't detonate a device just anywhere. You need secrecy and specific geography, distance from population centers, enough rock mass to contain the shockwave, and stability to prevent radioactive leaks. That is why Pyongyang selected Punggye-ri, in the country's northeast. At the site's core rises Mount Mantap, a granite peak more than 2,170 meters high. Height and density made it ideal for underground detonations. The mountain offered natural containment, its isolation, operational discretion. Over the years, engineers carved an interlaced tunnel network leading to deep test chamber spaces designed to absorb the unthinkable while keeping the surface outwardly serene. From the outside, silence. Inside, each blast hollowed cavities, collapsed galleries, and compacted rock. The entrances known as the north, west, south, and east portals let operators rotate test areas. Some zones stayed intact while others were pushed to the brink. It was the delicate balance between function and failure. Granite, the fortress. Why granite? Because, unlike softer rock, it withstands extreme pressure better. In an underground detonation, surrounding rock vaporizes for an instant, then the cavity collapses and the material densifies. Granite tends to contain energy and reduce the chance of radioactive escape. But no underground test is clean. Every explosion fractures the mountain, opens microfissures, and weakens structures once deemed solid. In Nevada and Semipalatinsk, history already showed, repeated detonations leave geological scars. Sometimes radioactive gases seep out, sometimes the surface subsides and craters appear. At Punggye-ri, risk was amplified by reliance on a single massif. With no international inspectors, outside understanding came from seismic networks, satellite imagery, and occasional defector accounts. Spoil piles near portals, vehicles, new construction. Each clue formed a mosaic of repeated use and mounting strain. The Ring of Unease. Mount Mantap lies less than 100 kilometers from China. Any serious accident could carry cross-border effects. Water and air currents move particles, tremors travel. Residents in northeast China reported windows rattling after certain tests. On the North Korean side, scattered villages lived with a low, persistent worry, shaking ground, rumors of collapse, fear of contamination. In a country where local voices seldom carry, concerns crossed borders in whispers. For Pyongyang, however, Mantap was more than rock, it was a symbolic stage. Each detonation said, wordlessly, we have crossed the nuclear threshold. But behind the symbol lay a physical limit: no mountain holds forever. September 2017, pushed to the edge. On September 3, 2017, North Korea executed its most powerful test to date. Estimates ranged from 100 to 250 kilotons, multiple Hiroshimas. The seismic event reached magnitude 6.3, followed by strong aftershocks. What shocked scientists, however, wasn't only the size, it was what happened to the mountain. Seismic and satellite data showed the unthinkable. The summit subsided by about 60 centimeters, and parts of the rock mass shifted sideways by meters as if the granite had turned liquid for a heartbeat. In seconds, a structure immobile for millions of years changed shape. Not mere damage, transformation. Mantap was no longer the same mountain. For many, this marked the turning point. The decades-old warning dash, repeated tests destabilized terrain, now had an undeniable image. A mountain yielding upon itself isn't a geological curiosity, it is a stark reminder of what nuclear energy can do to the planet. If that turning point surprised you, tap like. It helps more people discover this investigation, and what follows goes even deeper. The world sees the scar. Reaction was immediate. China voiced concern over contamination, Japan called emergency meetings, South Korea raised military readiness, the UN Security Council rushed new sanctions. For science, the subsidence became a symbol. Tests were not contained events, but forces capable of reconfiguring the crust. And the shock wasn't how we got here, the escalation. The seeds were planted in the 1950s with a Soviet research reactor. By the 1980s, Pyongyang was producing plutonium. In 1985, it joined the NPT, frictions with the IAEA grew. In 1993, it announced withdrawal, crisis ensued. The 1994 agreed framework froze the program for a time, then unraveled in the early 2000s amid uranium enrichment suspicions. In 2003, exit from the NPT became official. Tests followed, 2006, small, partly successful, 2009, larger, 2013, clear progress, 2016, two stronger blasts. Technical consensus, a move toward more sophisticated designs, possibly miniaturization for missiles and thermonuclear ambitions. Each blast brought condemnations, sanctions, isolation and leverage. For the regime, the arsenal is both shield and bargaining chip. The price in stone, water, and air. Since 1945, the nuclear age has etched scars in Nevada, Semipalatinsk, and the Pacific. Tests displaced communities, raised cancer rates, and dotted maps with radioactive zones. To limit harm came treaties, PTBT, 1963, NPT, 1970, CTBT, 1996, the last backed by a global monitoring network that detected, unequivocally, the 2017 changes beneath Mantap. Treaties, however, work only when honored. While major powers moved to simulations, North Korea kept detonating underground. The uncomfortable truth is simple: even when we don't see the flash, the shockwave remains. Radiation travels. Rock fractures. Waters shift. And sometimes, the ground sinks. After the shock, the question that remains. For Pyongyang, September 2017 was proof of strength. For the rest of the world, it was proof of fragility, of peace, of the mountain, of systems we thought we controlled. A mountain sinking 60 centimeters may sound technical, but it's the kind of number history does not forget. It converts megatons into topography, politics into geology. In the end, that test wasn't just another entry in the timeline of nuclear weapons. It was the moment we watched, almost in real time, the Earth yield to the weight of our choices. And you? Faced with a mountain that moved, should the nuclear debate be measured only in arsenals or also in the scars that remain? The world may long for the day we can finally say, it's over. But as long as these arsenals exist, danger will remain, lingering in the air, embedded in the soil, and even carved into the fractured rock of Mount Mantap. What happened beneath that mountain raised a question no treaty, no military exercise can ever answer. If a single test could move a mountain, what would a real nuclear conflict between nations do to our planet? This is the question that goes beyond politics and borders. How long can humanity endure living under the shadow of weapons capable of reshaping the very ground beneath our feet? Share your thoughts in the comments, and if this revelation made you reflect, the next video already awaits you here on the channel, with even more striking insights into the hidden risks surrounding our world.